Hello everyone, welcome to my channel. This is Kiran. Today we are going to talk about AWS Lambda MicroVMs. If you are building an application where multiple users or AI agents connect to a compute environment and run code, you need compute environments that starts fast, stay isolated between tenants, and don't require you to manage servers or networking. AWS Lambda MicroVMs are purpose-built for these use cases. They are serverless compute environments that provide VM-level isolation with full operating system capabilities, snapshot-based rapid startup speeds, and fine-grained control over ingress networking and egress networking. So let's get started. So before we go further, let's analyze evolution of Lambda execution environment. When Lambda was launched in 2014, AWS focused on giving developers a secure serverless experience so that they could avoid managing infrastructure. In order to attain the desired level of isolation, AWS used dedicated EC2 instances for each customer. This approach allowed to meet security goals but forced to make some trade-offs with respect to the way the Lambda was managed behind the scenes. Just 4 years later, it was clear that the serverless model is here to stay. Back in that time, Lambda processes trillions of executions for hundreds of thousands of active customers every month. Due to this, AWS adopted Firecracker. It is a virtualization technology that makes us use of kernel-based virtual machine. You can launch lightweight micro virtual machines or micro VMs in non-virtualized environments in a fraction of a second, taking advantage of security and workload isolation provided by traditional VMs and the resource efficiency that comes along with the containers. Lambda microVMs are powered by Firecracker, the same lightweight virtualization technology that has powered over 15 trillion monthly Lambda function invoked. Lambda microVMs, a new serverless compute primitive with AWS Lambda that lets you run code generated by users or AI in isolated, stateful execution environments. You get virtual machine level isolation, near instance launch and resume, and direct control over environment lifecycle and state, all without managing infrastructure or building expertise in complex virtualization environment. Now let's see what are the advantages a micro VM has over traditional VM or a container. The primary sweet spot is its security. That is always top priority. Firecracker uses multiple level of isolation and protection and exposes a minimal attack surface. Second point is it is high performant. You can launch a micro VM as little as 100 milliseconds, making it ideal for many types of workloads, including those that are transient or short-lived. Firecracker is battle tested and is already powering multiple high volume AWS services, including AWS Lambda and AWS Fargate. Firecracker consumes about 5 MB of memory per micro VM. You can run thousands of secure VMs with widely varying vCPU and memory configuration on the same instance. On top of it, Firecracker is an active open source project. Now, let us discuss how Lambda MicroVM works. So you package your application code and Docker into a zip archive and upload it into Amazon S3. You call the Lambda API to create a microVM image. Lambda executes your Docker file, starts your application, and captures a snapshot of the fully initialized environment. When your application needs an isolated environment for a user session, a job, or a sandbox, you call run microVM. Lambda launches a microVM from the snapshot with rapid startup times. Client connects to the running microVM through its dedicated HTTPS endpoint. No load balancer or ingress infrastructure is required. When idle, the microVM suspends, preserving memory and disk state while reducing cost. It resumes with memory and disk state intact when traffic returns. Suspend resume behavior can be configured automatically through a lifecycle policies or triggered directly via API invocations. When the session ends, you terminate the microVM to release all resources. Coming to the security and performance of microVMs. For microVMs, every session gets its own dedicated microVM, so there is no shared kernel and no shared resource between the users. If there is a malicious code due to AI-generated code or manually generated, it is trapped only within that box. It cannot reach other sessions or the underlying host. And the AWS operates in isolation, so the user don't have to build or harden his own hypervisor fleet. Now let's take the use cases of Lambda microVMs. Lambda microVMs is a good fit for use cases that executes user or AI generated code and require execution environments that offer strong isolation, rapid launch and resume latency, and developer control over environment lifecycle and state retention. The typical use cases involve interactive code environments where development environments where users write and execute code in real time, AI code sandboxes where ephemeral sandboxes for executing AI generated code safety, data analytics application, something like a Jupyter notebook and ephemeral data processing workloads that execute user supplied scripts, and also things like vulnerability assessment tools that need isolated execution environments, reinforcement learning environments that is isolated sandboxes for AI agents, evaluation and training where fresh environments are spun up for every run. It can be also used for multi-tenant CI/CD and gaming servers. Now it's a demo time. Let's head to a small demo. For demo purpose, I am following this particular link. I will share the link details in the description. For creating a microVM, first we have to create an IAM role and a policy, inline policy. So I have created this role in my system. So this is my role. I have created the role with the trust relationship of STS assume role and STS tag session. And also I have created an inline policy which has access to the specific S3 bucket where I am going to put my zip app file and also some log permissions. So once you do that, we have a sample app.js file. We need to create this file and a Docker file. Zip the file and upload to S3. So I have uploaded the file to S3. Now for creating the microVM, you can either run command in CLI or you can do it from the console. For the time being, I am doing it in the console. So for that, we need to navigate to Lambda and we can see the new microVM. First thing we need to do is create a microVM image. So I am going to create a microVM image. give some name. The base microVM image and the base image version, we will leave it as it is. Instance type is, and we are leaving it as it is. S3 file, I am selecting the zip file which I have uploaded to S3. Rest of the options I am leaving as default and click create. It may take a couple of minutes to create, so we will resume after the creation. So now the microVM image is created. Let's check that. Yes, it is created. Now we need to run the microVM. For that, click on microVMs and click run microVM. Select the image you created. Rest of the things leave it as empty and click run. If we check the link, it will show some commands to get the microVM details while it is creating and to run the microVM. So we have already done it through the console. So once you run the microVM, in order to connect to that endpoint, we need to create an authentication token. So if you can see that, you can see an endpoint here. If you browse this endpoint directly, we won't get the link. So what we can do is, in the microVM console, we have an option to create an authentication token. So before creating that, I will open my Visual Studio and use the Thunder Client extension to invoke the URL. I'll create a new request and I will choose the URL. As per the documentation, in the header, we need to give the header as X AWS proxy auth for the token. So I give the header, and now we will create the authentication token. Create. It is copied to your clipboard, so I will just paste it here. Now I send a request and we can see that we got the response. So that means the endpoint is working and is accepting the traffic. One more thing we can explore. Navigate to CloudWatch. Click on the logs and search for microVM. You can open the microVM. You can see the logs being generated. So you can listen to the logs through the log management system. So before finishing the demo, ensure that you are deleting the microVM and the microVM images, because microVMs are charged per second basis. If you forget to delete, it will incur charges for you. Select the microVM and terminate. Once it is terminated, select the image and delete. So that's all about the demo. We will come back to the presentation. Now let's conclude. So the key takeaways of this session are Lambda already runs on Firecracker microVMs. Your everyday Lambda functions have always run inside Firecracker microVMs. That's part of the invisible plumbing. Lambda microVMs is a new primitive. The new Lambda microVMs product takes the same engine and hands it to you as a serverless primitive. VM level isolation, snapshot fast launch and receive, and full lifecycle control, purpose built for running untrusted or AI generated code. And the sweet spot is the combination of security and isolation. The speed and scale of serverless with none of the infrastructure to babysit. So that's all from my side for today. So I'll be posting regular tech deep dives like this. If you like my video, please subscribe and thanks for your time.